going to just pick to keep my variables similar, the function y equals b to the x. In general, in an exponential function, we should know the shape of the graph, and then we should know at least two exponent rules. And the first one is, what would happen if I would put a 0 in here? It would be 1. So this would go through the point 0, 1, because anything to the 0 power is 1. And also, if I were to put in the point 1, b to the first is b. Now, I don't know what b is, but I'm just going to assume whatever it is, like let's say it's 3, that would be the point 1 comma 3. Or if it were 4, it would be the point 1 comma 4. So I'm going to just do it in general, and I'm going to graph the point 1 comma whatever b is. And then we draw a curve. There's a horizontal asymptote. Where is it? Now, some of you on your test made this look like it touched the x-axis. You definitely want to avoid doing that. You want to make sure that it looks like an asymptote. Okay. All right. So now, what does that have to do with what we do today? Because these are just inverse functions. What would happen if I switched the x and y's around? And that's what it would mean to be an inverse. Instead of y equals b to the x, what would I write? X equals b to the y. And we said, how could we write that in logarithm form? What's the base of the log? If you need to look in your notes, if you need to peek back in your notes, you can. Where do you find the base of the log? The base of the log is the same as the base of the exponent. So this is log base b. This y is on the other side, and the x is right here. So when you're given something in this form, really, this is just the reverse of that. The x's and y's are reversed, the inverse function. So if we think about that, let's pick those 2 points that I had graphed earlier, and let's figure out what would be on the inverse then. If 0, 1 is on the function, what point would be on its inverse? 1, 0. So all logarithms without transformations go through the point 1, 0, because this y value is the power, the degree, and what's anything to the 0 degree or 0 exponent? 1. Okay, the input and output are switched around. If this would be reversed, if 1b is on the function, what should be on the inverse then? b1. So I'm going to try to go over, I don't know where b is, but it's going to depend on what the base is, but definitely up 1. Alright, so now let's draw our curve. On an exponential function, there is a horizontal asymptote at 0. That's y equals 0. What happens in a logarithm function? Instead of horizontal, it becomes a vertical asymptote at x equals 0. And so I'm hoping that you can see the relationship between this and the exponential function. In fact, if I graphed them next to each other, they are mirror images of each other over the line y equals x. So for us today, I want you to acknowledge 3 things as we're graphing: the asymptote, the point 1, 0, and the point base 1. And so let's just talk about it a little bit. So if it was log base 2, even though we can't graph log base 2 on our calculators, okay, it would go through the point 1, 0, and what other point? Log base 2. What's the base? 2, so it would go through 2, 1. How about log base 4? We would go through 1, 0, and the point 4, 1. How about the common log? What 2 points should that one go through? 1, 0, and 10, 1. How about natural log? 1, 0, and E1. And E, when we graph it, we're going to just estimate it to be about 2.7. Okay, 2.71. All right, so then let's take a look at how we would analyze something like this. And then we're going to do an example where we really graph something with a transformation. Okay. All right, so if we're taking a look at logarithm graphs, so this is where we're focusing today. What do you think the domain is? What does it look like? Zero to infinity? What does it appear that the range is? Bottom to top? All real numbers, good, or negative infinity to infinity. Where is this continuous? You can say on its domain, just don't say everywhere because it's not continuous over here, it doesn't exist over here. So I'm going to say continuous, uh-oh, I forgot a U. On the interval 0 to infinity, which, yes, is the same as its domain. How about, is it increasing or decreasing or anything like that? It's increasing from 0 to infinity, right? All right, does this have any symmetry? By symmetry, is it even or odd, I guess is what I'm saying. Nope. It doesn't. How about, does it have any extrema? Nope. So I'm going to write no symmetry, can't spell today, or extrema. It is not bounded. These are all things I potentially could ask you, so that's why I'm addressing them. We call this analyzing, right? Let's get to asymptotes and end behavior then. Yep, this has a vertical asymptote. We talked about that earlier. X equals 0. And end behavior is kind of interesting on this one. Normally when we do end behavior, we go X goes to the left, what happens over here, and then what happens over here. But what's the problem with over here? Doesn't exist. So this time we don't do both end behaviors because there's nothing to do on this side. So we just do this side. Okay, so we're going to just say, what is the limit as X goes to infinity, so as X goes to the right, even though it's slowly, what is the function doing? Going up, 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 up. So we're going to say f of X also goes to infinity. And so that's how we would analyze, in general, the graph of a logarithm. But any logarithm without transformations would follow that. It just might have a different second point. It would still have the same asymptote. Okay. But how would we do something with transformation? So how would we sketch graphs? We've done this throughout with every single function. How do we sketch graphs? We're going to take these 2 points in the asymptote. We're going to do a transformation now. Okay? Let's take a look at one. How is g of x equals the natural log of 3 minus x related to ln of x. Trigraph. Okay. So sometimes it's hard to see transformations when they're written like this. Notice that these are both with x, okay? So the first thing I'm going to do is I'm going to just rewrite them. So I'm going to rewrite g of x as the natural log of, instead of 3 minus x, can't I write that as negative x plus 3? So I can see the transformations a little bit better. So does anybody know what two transformations have occurred from ln x? That means left 3 reflection over y-axis. Now, sometimes we have to be careful of the order. This is one of those cases. Because if I reflect something this way and then shift it that way, if I do the wrong one first, I'm going to end up in the wrong spot. And so what we remember with x is he's a liar, right? So I always go, if I want to list them, I list them backwards. I'm going to write the address, the plus 3 first. That means shift left 3 and then reflect over the y-axis. Okay. And so now I'm going to draw a graph, and I'm going to use my knowledge of the original graph. One, two, three, four. That's good enough. Okay. Let's very, very lightly on here sketch a graph of natural log of x, okay, before the transformation. Where is its vertical asymptote? 0, right? And it goes through what points? Come on, guys, we just did notes on it. Go through what points? 1, 0, and then it's base 1, which is approximately 2.7, so I'm going to just approximate. Okay, so here's my sketch of ln, okay? Goes through 1, 0, and E1. All right, so if I shifted it left 3, does it make sense that it's almost like this whole thing shifts over? Do you see how it would go like this now instead? Does that make sense what I just did? I move the asymptote over, I move my 2 points over. Okay, good. Now, what happens when I reflect that over the y-axis? Well, let's do it. Reflect this line over the y-axis. Instead of that negative 3, where does it go? Positive 3, and instead of the graph going this way, it's going to go the other way. Okay, so in a darker color, what I'm going to do is I'm going to put my asymptote here, and then I'm going to go 1 over, but I'm going to go 1 this way, and I'm going to go 2.7 over 1, 2.7 over 1, but I'm going this way because it was reflected. Alright, so let's take a look at how we did. This one we can check on our calculator because it's a natural log. How did I do? Does it look right? Okay. So a couple things to keep in mind. My expectation is that you don't just look at your graph and you just stop your graph. You should know this is a graphing calculator error. The graph cannot continue because it graphs by increments. So if it hits a vertical asymptote, it has to stop. So that's why this stops. But the function really doesn't stop, and you need to know that. Okay? But it looks like it's exactly the same. Okay, questions on that?